Alright, so till now, authors have enhanced the existing self-supervised approaches, particularly focusing on discriminative methods, and demonstrate that with sufficiently large and curated datasets, such models can produce features surpassing those from weakly supervised or text-guided models. Now, let's look at how this model handles fairness and bias. You can see that the Dino version 2G model performs consistently higher than the CL version 2 across all regions and income bands. However, if you look at the numbers for Africa and Europe, still a sharp drop, about 26 percentage points lower in Africa compared to Europe. Similarly, the model is about 32 points less accurate for low income homes than for the high income ones. Now, uh, this usual pattern shows that while this model is fair than the previous models, it has still a bias towards rich images from rich and western countries. Now shifting to the people attribute test using the casual conversations dataset, look at here that almost all faces regarding regardless of gender, skin tone or age are tagged as human. That's the dominant color in the table. Now harmful labels like non-human or crime are almost never assigned. There's a small effect for men where the possibly human label appears more often, and that's because of the beard class in the data. But there's no clear harmful bias by gender, skin tone, or age. So the main takeaway is that curated self-supervised learning improves fairness, but as you can see, the regional and income gaps are still needed. Are still We still need more diverse and underrepresented images to fully close these gaps. Now, before moving on, let's look at this visual, figure 10, matching across images. This figure demonstrates that one of the strengths of this model's features. The lines connect semantically similar regions between different images, even when the objects or domains change. For example, the model can match the wing of a plane to a wing of a bird, or similar parts across photos and drawings. This ability to find meaningful correspondences despite changes in style or pose highlights how these models learn features generalize across domains. It is a qualitative sign that the model is learning more than just superficial patterns. It is capturing deeper visual semantics. Now let's look at the closer at the table 12, which breaks down geographical fairness and diversity. You can see that the accuracy numbers for this model and this year version 2 across different income buckets, low, medium, high. Now notice that the Dino versions 2 numbers are higher in every column, but pay attention to the gap. 67.4% accuracy for low income and jumping to 90.5% for high income. That's a 32-point gap we mentioned earlier. On the right, uh, table shows that table showing performance by region. Again, this model outperforms this year version 2 everywhere, but the gap between Africa and Europe is still clear. So this table reinforces that while this model is a step forward, still there's a strong western wealth tilt in its predictions. Now, let's look at the table 14, which summarizes how the model assigns labels across gender, skin tone, and age groups. Look at the human row for this model. Almost all values are above 84%, and most are above 90%. The non-human and crime rows are essentially zero except for a tiny blip for male darker, and that's just 0.2%. The possibly human label is more frequent for males, especially those with darker skin, which, as mentioned, is due to the presence of a beard class. So the visual, so this confirms that this model assigns human labels consistently across demographics with no systematic harmful bias detected in this evaluation. Now let's talk about the environmental impact of training these models. If you uh, This model requires about 22,000 GPU hours, which translates to roughly 3.7 tons of carbon dioxide emissions. That's based on US grid averages and a PUE of 1.1. If you compare this to a text image model like Clip, which needs a text encoder as well, the emissions are about 10 times higher for the same size model. That's a huge difference, and you can see it in this table. Here it mentions the GPU hours for this model, and it compares. Yeah, now the total emissions for the whole Dino version 2 project, including repeats and ablations, are kept under 1000 tons of carbon dioxide emissions. One important note visible in the table is that these numbers are only GPU, only count GPU electricity usage. They don't include carbon cost of manufacturing or disposing of the hardware. So the takeaway here is that visual only models, self-supervised approaches, for visual only models, self-supervised approaches like this model are much more carbon efficient than the text guided ones.